Hey guys, welcome to the next video in Diels Alder. This one is going to be just about practicing what we talked about in the previous video regarding the regiochemistry of the Diels Alder. Right, so what is again the regiochemistry? The regiochemistry is like in what way we're going to be connecting our two compounds, the diene and the dienophile. We haven't talked about the stereochemistry in a Diels Alder yet. That's going to be in the next video. Alright, so this one's just going to be practicing. So let's get started with example 1. So here's our diene and here's our dienophile. Right? Remember the diene has these two conjugated double bonds. The dienophile has got that single double bond, no conjugation with another sort of diene like that. Okay? And so remember when talking about when we're doing these reactions, we have to look at our donating groups and withdrawing groups. So where is our donating group, or what's actually on the diene? Well, here's the normal part of our diene, this part. What's different is the methyl. This is going to, remember, alkyl groups are electron donating groups. So this methyl is going to put electron density into our diene. Now remember, this methyl group doesn't have a resonance, right? It doesn't have lone pairs because there are 3 hydrogens coming off of it. But in order to help us use it in a Diels Alder and figure out where the charges are, remember that partial positive and partial negative, we're going to pretend like it has resonance. So the way I'm going to pretend it has resonance, I'm going to put a lone pair here. This is just my strategy. Remember, there is no real lone pair there. Okay, so do not think that there is. This lone pair is going to come down and form that double bond. And now what we're going to do is we're going to have to bring this guy up. All right. Now what you do not want to do is make the mistake of bringing him downward and then moving this guy over there. What that's going to do is going to give us this resonance structure. Now remember, again, this isn't a real resonance structure just because we don't have that lone pair there. And that positive charge. This is going to break an octet. We don't want to do that. Okay? So what we're going to do instead, this guy comes down, and we're going to bring him up. Now you're going to get a negative charge up here. And we're going to have this kind of this compound. And like, okay, you could have a plus charge here, but again, we're not really concerned about what's going on with the methyl, more about that partial negative. So we see that that partial negative, that negative is right over here on this carbon. So what I'm going to do is on this diene, put that partial negative on that carbon, just so I know it's this carbon to keep track of it. Now let's work on our dienophile. Let's redraw it. So how do we do the resonance for this guy? Well, here this is a lot simpler. This double bond is going to come up over here, and the carbonyl double bond resonates up. This is going to give us this resonance structure, giving us a positive charge on this carbon, this bottom carbon. So that means on this structure, the partial positive is on that carbon. Just make that a little neater. Okay. So now we can connect it. So we like we said in the previous video, we want to line up that negative and that positive. They're attracted to each other, right? Electrons like to flow from an area of high density to low density. So that means we want to connect this carbon in red to this carbon in blue. All right. As it is now, we can't do the Diels Alder where this carbon connects to here. Okay. So what we're going to do is just flip either the diene or the dienophile, so we can have the blue and red carbons directly across from each other. Doesn't matter which one you do, right? They're going to give you the same product. So I'm just going to flip the diene to look like this. Now, that carbon has that partial negative. And if you're still a little shaky on it, you could go through that whole like fake resonance thing again. And redraw the dienophile. Alright, so here's our partial negative and positive. Now we can do the Diels Alder, and here are the arrows, right? And so draw that 6-membered ring. And let's number the carbons actually. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Carbon 3 had the methyl. Carbon 6 had the ester group. Remember, carbon 2 and 3 are going to get a new double bond, right? You can see from this arrow right over there, right, this guy. We're moving that double bond between carbon 2 and 3. And the other two double bonds between 1 and 2 and 5 and 6, they form the single bonds, right? And so that's going to be the answer to this question. Now remember, we can do a check kind of. What you want to do is see if the donating group and withdrawing groups are either 1, 2 or 1, 4. If you get a 1, 3 regiochemistry, you did something wrong. So let's count it up. 1, 2, 3, 4. Good. And like I said in the previous video, you can count from starting from the withdrawing group or the donating group, doesn't really matter. And so we have a 1, 4 regiochem, so we did the problem correctly. Okay, let's go on to the second example. So we have our diene and it has this OCH3 on it, and we have our dienophile with this CN group, that cyano group, that nitro group. That is a withdrawing group, okay? And so we have our OCH3. So let's draw the resonance from it. This guy has 2 lone pairs. So that oxygen gets a plus charge. We're going to have a negative on this carbon, and the double bond is there. So our partial negative is on this carbon. So let's put it right there. Let's look at that cyano group. Now the cyano group can look a little bit tricky because it looks like this. Okay. And so all we have to do is just bring this double bond here. This guy comes over here. And that nitrogen has 1 lone pair. Now he has 2 lone pairs. And if you did the formal charge, you'd see he has a negative charge. And this carbon right here, he has the positive charge. The partial positive we need to worry about. So that's this carbon. Okay? And so now you can see that the partial negative and positive line up perfectly. We don't need to worry about flipping anything around. So let's start out. Let's just number carbons first. 1, 2, 3, 4, 5, 6. Okay. Now again, Diels Alder. Here are the arrows. And let's draw our product. 6-membered ring. Number it up again. 1, 2, 3, 4, 5, 6. Carbon 1 had our OCH3. Carbon 6 had that cyano group. Or you can hear it be called a nitrile. Now we know again in the Diels Alder, carbon 2 and 3 right here, they're going to get that double bond. Alright? And there's our answer. And now let's just make sure that we have that regiochemistry, so either 1, 2, or 1, 4. So just in case, if you count it, if you renumber it this way, 1, 2, 3, 4, 5, 6, you're going to get, it's not going to look right. So we always have to start either at the withdrawing group or the donating group. So in this case, we start at the donating group. So now, because that count didn't work out, just go the other way. 1, 2. All right? And that's that 1, 2 regiochemistry. So that was good, and so we did this problem correctly. All right. And so I will see you guys in the next video. We're going to be covering stereochemistry in a Diels-Alder reaction. All right. Good luck.